Bonjour tout le monde, bienvenue à un autre séminaire d'Ouranos aujourd'hui. Merci de vous avoir connecté en grand nombre pour deux présentations au sujet de la résilience du secteur énergétique face au changement climatique. So hello and welcome to this Ouranos seminar. Today, webinar. Thank you for joining us in large numbers for our two presentations on climate resilience in the energy sector. I'm Marco Braun, and I work in the Climate Scenarios and Services group at Ouranos, where I often had the pleasure to be involved with projects around the issues of climate change and climate resilience, climate change impacts on energy business, and there particularly our consortium members. And I've had the pleasure of working closely with our presenters today, so it's my great honor to moderate this event. We will have two presentations who dig a little bit into how to carry the adaptation process from the asset level to more a corporate level. And I would like to ask you for the duration of the presentations to please close your cameras and your microphones. If you have questions, feel free to type them in the chat, be it in French or in English. So I guess we just go ahead and get started with our first presenter, who is Kurt Kornelsen. Kurt received his PhD from McMaster University, studying in the Water Resources and Hydrological Modeling Lab. And he became the first network manager of the NSER Canadian FloodNet as a national research project to study the forecasting and impacts of flooding in Canada. In 2017, he joined OPG as a senior manager of water resources. He's currently responsible, including the oversight of a team of engineers responsible for developing inflow forecasting, hydrometric data and analysis, OPG's in-house expertise in climate science, hydroelectric licensing, and water policy and planning. So Kurt, the pleasure is mine. The floor is yours. Please go ahead.
Excellent. Thank you for that nice introduction. I'm just going to get my screen shared here. Let me know if you can see it.
Yeah, that's perfect.
Okay, great. Are you also seeing I've got your faces here blocking half of my slides? Can you see that or no?
Yes, you can move that to the side, I guess, or people can collapse it.
Okay, so there, I think I've got it off the screen. So yeah, thank you. It's great to be here talking about OPG's Resilience Toolkit and our process going forward with climate change. And I just want to highlight within OPG, there's several organizations or business units that have some responsibility for climate change. And so my particular group is really focused on the climate science. So we are kind of more like OPG's internal service provider. We're developing a lot of the technical work. There's other organizations, though, business units that are overseeing also some of the programmatic development when it comes to climate change. But today we're going to be talking about OPG's Resilience Toolkit, and particularly some of the processes that we're in the process of developing and how we've used in particular Ouranos's PAVICS system and how that's being integrated within those processes. So in terms of the agenda for today, when we talk about is a little bit of the philosophy behind our Resilience Toolkit and our approach to dealing with climate change. From that, I'll give you an overview of the climate atlases that we've had developed, how we've rolled those out and communicated those, how that fits into our broader Resilience Toolkit. And then also, since we are talking about a PAVICS and also a lot of the XCLIM module that's been developed, some of the upcoming uses we're seeing for, or we're trying out for XCLIM. So by way of introduction, OPG we're a private company, actually, where shareholder is the province of Ontario. We are the major generator within the province of Ontario. We also have a US subsidiary called Eagle Creek Renewable Energy. For our purposes, in terms of my responsibility, it's focusing primarily on OPG proper, which is actually just within the province of Ontario. So within the province, OPG operates our 2 nuclear stations, which have a combined capacity of 6,600 megawatts. We operate 2 thermal stations, 1 solar facility, and where I spend most of my time is on the 7,478 megawatts of our Ontario hydroelectric fleet. So you can see that we do have 66 generating stations. There's also 241 control dams, and all of those are spread throughout the province of Ontario. So very recently, OPG launched a new climate change strategy. I believe this came out in 2020. And OPG committed to take action on 4 major topics related to climate change. So number 1 was mitigate, to reduce our carbon emissions towards a goal of net zero by 2040. Ones we're focusing on today more are coming on the adapt side to ensure our operations are resilient to the impacts of climate change. And also what we're hoping is the lead and innovate and how we integrate some of that climate change strategy into our day-to-day business processes. So one thing that's important to recognize is that for a hydropower company, there's a lot of ways that climate change can actually impact us in the energy sector. And so when we have those 66 generating stations and those 241 control dams, plus all of our other assets and facilities, it's a very complicated network of how these set together. And there's a lot of different people who are involved in the day-to-day, the running, the projects, the asset management, the uptake of all of those stations. And so one thing with that scale of a fleet that you very quickly realize is that our climate change group simply can't do it all. If we want to ensure that our assets are resilient as we're looking at this host of impacts, we need some way to ensure that our line engineering groups, our line asset managers can also be thinking about climate change. And so that was kind of a fundamental realization to the philosophy and the approach that we are taking to address a lot of the climate change challenges that we have. So I want to talk through a little bit about at least what I observe as a typical process for doing adaptation to climate change. I can call this more of the organizational scale approach. More often than not, what happens is an organization will look for a third-party vendor to do a vulnerability or an adaptation assessment. So they're going to look at the entirety of the organization and try to do some sort of analysis to figure out what those major vulnerabilities, major risks are going to be. So it's usually a very high-level assessment, and very often it's going to be based on interviews or sometimes expert review. So what we would see is someone or a group go to each of these individual units and they would say, hey, Hydro, how do you think you're going to be affected by climate change? We're seeing temperature increases. We'll see some increase in precipitation at the end of the year. How do you think, or sorry, the end of the century? How do you think that could potentially impact your assets? And then they would have the people who are kind of experts in those systems come back and say, well, we might get this impact, we might get that impact, and we think this could be high and this could be moderate and this could be low. And so that usually is the process that gets followed in a lot of organizations. And at the end of that, what we end up with is a single report that takes all of those different risks that people have identified through that review process. And usually you would see some sort of a ranking of those priorities. Now, what happens with that report on the aggregate scale is often the top couple of risks are something that gets chosen to be addressed. And so we have a couple of challenges with that approach, right? It's organizational level, whereas at a generating station itself, I could have several components that have a risk to climate change. The other thing is I could see a different set of risks, like for us in OPG, in Northwest Ontario, we tend to have a different climatic regime than what we see in the Great Lakes Basin. And so what might be a risk to one facility could be very different at another. The other challenge that we have is those become what I'll call quote unquote adaptation projects. And that can often be a difficult type of project to fund. To say that I have a risk in the future, I want to spend some money now to address that. And then we usually have to go to some sort of an economic regulator. So in Ontario, that's the Ontario Energy Board. And we have to make the justification of why we're spending that money, why it's in the best interest of Ontario ratepayers, and why it's in the interest of Ontario ratepayers to fund that project right now. Why can't it wait until the future? And so often when we're looking in a corporate business planning cycle, you're looking at maybe 3 to 5 year increments. And so the question is always asked, okay, in this 3 years, what's changed from the past 3 years? And as you know, when we're talking about climate change, the answer is usually not much. If we look at a very short window, the change between this short window and the last is very small. But over time, that adds up into what could be a more significant change. So it becomes very difficult to take that sort of report and turn it into real actions. And so what more than not happens with these sorts of high level assessments is it's good to start giving some direction, but it usually ends up, as you see in the picture, as a report sitting on a shelf collecting dust. And so that's not where we want to go, because it's not, in my opinion, the best way to drive some action forwards. The alternative is we have an expert adaptation group. So there are a number of organizations that have hired individuals that have expertise in climate change and hydrology in relevant fields. And they are the ones that are doing a lot of the climatic assessments. And this is also a very good approach, but it has its pros and cons, just like everything. So number one is you're not going to have experts in all of your systems plus climate change. So that group of individuals you have that are focused on climate change are usually tasked to a finite number of projects. So there's always going to be these resource constraints. That's natural in any organization. And so that group can often do very strong detailed analysis of specific problems or projects that are of the most importance to the organization. But you also run the risk then of facing challenges with some of your complex systems or certain aspects of climate change. So for example, if you're going to have your expert group look at the impact of climate change on a particular generating station, they would usually focus on our cases, for example, the dam safety analysis. What could be the impact of your inflow design flood? What's going to be the changes in water flows and levels? And how does that relate to the energy production? But sometimes you might not be getting down to the individual system level just because you are limited in the scope that you actually have available. So for example, are you looking at the impact of climate change on your transformers? Are you looking at the impact of climate change on your transmission distribution system to that station? Or even down to the level of what's going to happen in terms of extreme rainfall in some of my drainage systems. So there's a lot of aspects of climate change that could impact individual systems that expert group just might not have the scope or the resources to be able to tackle all of them. And so OPG's attempt at dealing with climate change is to try to integrate this concept or the consideration of climate change into our day-to-day business practices. What we want to do is take our group that has some expertise in climate change, that has our direct relationship with Ouranos, and use that to be able to create the products, to create the knowledge, so that 80% of the work that we do can be taken care of by OPG's line engineering. And then when we get to the difficult or the complex challenges, that smaller 20%, that can be followed through by the group that has the greater expertise to do that. And so in order to do that, what we need to do is make sure that we have the climatic data, the products available. We need to make sure that the line engineers have the right knowledge to be able to use that in their typical decision-making processes. And we need to make sure that it's integrated into the business processes. So they have to go through and integrate that into their designs, into our asset management framework. Because otherwise, it's a lot easier to not consider climate change, to go to a business as usual process and be able to push through a project or redevelopment just a little bit faster. So there's a couple of key challenges that we need to address to do that. So we've got to develop the data and the products for those people to be able to use. We need to make sure that they have at least enough of a basic knowledge of climate change and addressing uncertainty so that they can implement those products. And that takes a lot of, we got here, training. and also enough tools so that they know how to integrate that into their analysis. And so where we are now is also working through the process of establishing our corporate governance and our corporate business processes so that we can integrate climate change into an existing process rather than having a climate change assessment as an external process. So rather than creating something new, what we want to do is take this concept of climate change and embed it as much as we can into something that already exists. So that way it's not as much of a disruption for the organization. It's just a step along the way. So we have this as our, what I call our roadmap to application. And so this talks a little bit about the evolution of how we've gone through this process, particularly with Ouranos and others. So OPG became an affiliate member of the Ouranos Consortium around 2008. And so between that period, 2008 and 2019, we really started going through the typical process of how's our flows and levels going to change? What's going to be the impact of climate change? Let's look at some of these different types of meta scale analysis. And at that time, we started to think through, okay, we've got some research, we've got some background. Now, so what? What are we going to do with it? And so we began the journey of now integrating that into our business processes. So one of the first places we started was we actually had Marco and David come to OPG and do what we called our speaking tour. So we brought them around the various sites at OPG where we could get a lot of people, and had that as an introduction to climate change from everybody from the CEO all the way down to line engineering. And that was a very well received exercise, because then people had a better understanding of what was climate change, where was the information coming from, and what could some of the potential impacts be. So following that, you'll see a lot of activity in the 2019, 2021, a lot of overlap here. But in 2019 and 2020, we developed the first and the second edition, or we finalized those editions of the OPG Climatic Atlas. And so that provided basic data that people could reference as it relates to climate change. We started looking more at some of our asset valuations, some of the projects that we were undertaking in various ways. So as it became now a requirement, we were looking at climate change through our environmental assessments for some of the projects that we did. And also you'll see here the Little Long Spillway project, which is a dam safety project. That was actually referencing a specific research project that we undertook with Ouranos and others within the industry. In 2021, 2022, we now have a project to develop our new, we call it our hydrological prediction system. So OPG is building and expanding its capacity for hydrological modeling. And so that is a real-time operational adaptation, but it also gives us the in-house models and the knowledge that we can use and transfer some of those models directly into our climate change processes. So we're still working through that, building the foundation. And then starting in 2020, we also started integrating considerations for climate change into our business planning and our project integrations. So we now have information that's required for every business unit as it relates to climate change to identify if a project that they're doing, for example, can help build some level of resilience, or if it addresses a climate vulnerability, if an assessment has been done, or if an assessment is needed. So right now, those are still very high level flagging that has to get done in the business planning process, but we can start tracking which projects we're going to undertake that have some potential to build resilience for us. And so these are some of the key areas that we're looking at of where can we go to integrate climate change. So number one, into our risk management processes. So what could climate change pose in terms of our business risks, risks to an individual project, operations, or some of our safety assessments, particularly when we're looking at our long-term safety assessments, for example, of our dam safety, our public safety programs, when we're looking at our plant health. So from the risk side, then we move into our asset management. So when we are actually going out and doing a comprehensive assessment of our plants, of our systems, when we're developing business cases in order to do some sort of an upgrade, we're looking to have the tools that people can explicitly look at climate change in those systems. In fact, we're already seeing a lot of questions related to that, where people are truly realizing the risks. So when they're saying, you know, things are really changing, I'm seeing a big change in water and it's impacting me in some way, it's all operational experience, but people are becoming more and more concerned and more aware of the impacts of climate change. And they're looking for ways to integrate that into more of their long-term planning. And then, of course, we get into the side of emergency management when we're looking at our hazards assessments and some of our beyond design accidents. So looking at things like the impact of potentially tornadoes, which is something that has actually impacted OPG. And so that does become harder from a climate change perspective, obviously, as you're getting into things like extreme tornadoes versus temperature and precipitation changes. But those are the sorts of things that and we're starting to look at and consider. So getting more into the XClim and the PAVICS integration is the OPG Climatic Atlas. So we've now released 2 editions of the Climatic Atlas. So the first edition was finalized in 2018. And what this looks at is temperature and precipitation data at a fairly large scale across OPG. And so,
yeah.
Sorry, someone needs to mute their phone.
Yeah.
Or their microphone.
Mm-hmm. Yeah. Mm-hmm. Mm-hmm. Yeah.
Sorry, maybe as someone has their microphone on. Can we please close that?
I see that. Mm-hmm. Yeah.
So Shirin Akari, Shirin Akari, will you close your microphone, please?
Marco ou quelqu'un d'autre, il y a peut-être. Ah, voilà, c'est fait. C'est beau. Bravo.
OK.
Okay.
Merci.
Sounds.
Pas trouvé. Thank you. Sorry.
Okay, thank you for that. So the first edition of the Climate Atlas was primarily developed by Ouranos, and OPG had some contribution to the final internal report and produced some of the custom figures based on the data that was provided. So the main focus here, and you'll see some examples of the products, was the change in temperature and the change in precipitation across OPG watersheds. And the focus was much more the broader watersheds, not some of the sub-basins within it. And so there is the other thing is that we focused on seasonal changes and annual changes. So for each of our watersheds, you'll see an example of this map of what's the difference in summer precipitation for the 50th, 10th, and the 90th percentile of an ensemble of climate models. And so this was produced basically for each of our seasons, for looking at the difference in summer and winter, spring, fall. The other thing that we did in-house is we took that data, and you see the bottom figure is creating these little graphs to show what is the changes, what is the trends. We also did some analysis to figure out how likely those changes were. We provided that information as part of this first version of the Climatic Atlas. And so that report was shared, as well as the map book, and made available within our corporate record system and on SharePoint. So OPG adopts a lot of Microsoft systems. So our main website, the way we communicate with others within our organization, is through SharePoint. So that was the first edition of the Climatic Atlas. And then in the second edition, as this one was being developed, we were taking more of the mindset of how do we support our line of business for doing analysis. And so within the second edition of the Atlas, we took in new considerations for training and information sharing. We wanted to make the data within the Atlas more widely available to others within OPG. At the same time, the PAVICS system had been developed. And so we were certainly looking to capitalize on all the other indicators and analysis that was available through PAVICS using the XClim library. And so this atlas was actually primarily developed by OPG using the PAVICS system. And I can't understate the amount of support we got from Travis at Ouranos. It was really great because we had the good starting point in terms of being able to use those sample scripts anytime we ran into some big issues with debugging or some of the performance issues, Travis was able to kind of get us steered and pointed in the right direction to keep moving forward. But it was a good working relationship, and I think a good model to get us the product that we wanted. But obviously we had to be willing to invest also the time and effort and have the right expertise to be able to do the programming and do that analysis within PAVICS. So the Atlas itself, as we consider the second edition of the Atlas, is actually an assortment of different data products. So number one is we have the Atlas report itself. And so this has a description of climate change, and I'll get into some more details of what's in the Atlas, but also instructions on how that data can be accessed and used. We also develop site data. So we have a number of indicators that were available, and we produce those for each site. We did some statistical tests so that people have an understanding of how impactful, or I guess how real those changes are from a statistical sense. And we created a map book so that people could have an understanding of the maps and the spatial relationships. And the other decision that we made in developing this, and you can see this in the figure, is that we no longer took the watershed average. We decided to provide the gridded information to our users so they could see the spatial pattern of how climate might be changing. So certainly that's very impactful at the scale of Ontario. We also have some very large watersheds that OPG operates in. And so we do see climatic differences across the scale of the watershed. And certainly we also have smaller watersheds where there's no difference or value added from this gridded approach as well. So within our current version of the Atlas, we have 30 indicators in total, and those are based exclusively on precipitation and temperature data. And so we do have an ambition in the future to expand that as more indicators become available within XClim to do more of that calculation and turn this Atlas into a little bit more of a living document. So the indices that we have are from XClim. They're based on the CCCS data set, which is already in PAVICS. And so we're looking at a lot of different types of indicators on extreme temperature, what's our average temperature changes, changes in average and extreme precipitation, things like growing and cooling degree days, as well as some of our ice days, looking at indicators of, for example, freeze-thaw cycles. So within the second edition of the Atlas itself, you can see on the right exactly what this looks like on our OPG SharePoint site. So the report itself is the primary reference for this whole Atlas. And so we took this as an opportunity, if people were going to look at the data in the Atlas, to also treat it as not just an Atlas as a map book, but also as a tool for education. So within that Atlas, we also give a primer on climate change models. We talk about what is downscaling, what is the importance of that, what are the indicators that we have used. We also give a synopsis of Canada's Changing Climate Report to give some sort of a reference for people of here's what's being seen in the broader literature to provide that context for what could be seen within the Atlas. And a lot of these indicators, especially in the initial version of the Atlas, are the same as what we're seeing on the Canadian Centre for Climate Services, or the climatedata.ca website. The big advantage, or the one thing that we felt was really important for OPG, is on that site, you see the 50th, the 10th, and the 90th percentile of the ensemble of climate models. What we wanted to do was give our engineers, our asset managers, our designers, more granular information on the various of the probability distribution. So for example, if you had a distribution that was skewed, either high or low, we wanted to make sure that they had that information available to them. And so that was one big difference from the data that's just publicly available on climatedata.ca. Within that report, we also gave a lot of tips and how-to of, for example, how do you interpret the uncertainty that's being provided within the climate change? What is the difference between taking that data raw? How would you apply, for example, a simple delta change approach? The other thing we did was different types of analysis and statistical tests. We provided that information to our end users as well. In terms of the maps, So for all of the indicators, we also produce watershed maps. So for every watershed that OPG operates in. So for example, you're seeing here the Ottawa River watershed. And so one of the big things is this is a very large watershed again, where there is a spatial difference in terms of the impact of climate change. So this is one of those reasons that we maintain that gridded data. We chose on the maps to maintain the 50th, 10th, and 90th percentiles, simply because there's only so much information that you can show. And we produce those for RCP 4.5 and 8.5. So in this particular example, we're looking at the most future period. What are the days above 32 degrees, or how many days are there going to be above 32 degrees Celsius? And so we recalculated all of this information for all of our watersheds within PAVICS using XClim. And so all of these maps, we've created these within the Python script, and they've all been posted now to SharePoint as a PNG image, so that anyone can take that image within OPG and be able to use it. We also produced individual data files. So for every single site at which OPG operates, so for every dam, generating station, as well as the major cities for the markets we participated in, we took the single grid cell in which that facility was located, and we extracted that data. And we made that available, as you can see here, as an Excel file. So what we did is we calculated those indicators within PAVICS. We exported that as a netcdf file. We downloaded those netcdf files, and we created a separate script to turn that netcdf into this Excel format like you've seen here. So what we have in this case, instead of just the 50th, the 10th, and the 90th, we have the annual value of an indicator for the 1st, 10th, 20th, all the way up to the 90th, and then the 99th percentile. So a user looking at this data will have a very good sense of what that probability distribution actually looks like as they look out into the future. So you can see here, we're actually looking at, again, the number of days above 32 degrees Celsius. We have across the tabs at the bottom for RCP 8.5. You'll see a lot of zeros in the first few columns, but as we get out closer to the 50th percentile, you start to see the number of days growing in this particular example. I think this one is actually for the Abitibi River in Northern Ontario. Sorry, the Abitibi Canyon Generating Station in Northern Ontario. So not only do we provide this Excel file, because that gives people the freedom to do the analysis they want to consume it in their own way and get an understanding of the data. We also pre-created some time series figures that they can use using an R script that was also made available to them. So that is in all of the data files now sitting on SharePoint. We also undertook an additional analysis so that people had a sense of whether or not a change was particularly significant. So we used the Wilcoxon Rank Sum test, and we test the 30-year mean. So we treated all of the ensembles as a sample over a 30-year mean, and we looked at if there's a statistically significant difference in the averages between these different 30-year periods. And so again, we provided that analysis as an Excel output. So we calculated it in R, output it to Excel, but we also pre-created these figures, which are also available for everybody. So in this particular case, this interpretation is the 30-year period centered on the 1970s. We can see here that it's not actually significantly different from the 30-year period centered in the 1990s. So we can see, number one, is it significant or not, but also the p-value in the bottom half of this matrix. And as we get up, we see a lot of orange telling me that 1971, yes, was significantly different than the 2010s, 2030s, 50s, 70s. And we can see again, as we look into the future, all of these periods become significantly different from each other. So that gives people an initial indication that yes, there is or there is not a significant change in those periods. And again, that is done for every single indicator. So in this case, we're looking at total precipitation for RCP 8.5 for the Abitibi Canyon Generating Station. So once we've got all that data, we have to make sure that we're going to roll that out and we're going to put it into practice. And so I wanted to take just a few minutes to talk about how we rolled out that communication. So number one, the Atlas report is a fairly comprehensive summary. And it is my true hope that people will go to and actually use that Atlas and read it. That being said, I'm also realistic enough to know that's probably not going to be the case for everybody. And so we developed a couple of training videos. And because we are in the Microsoft environment, we had Microsoft Stream, which is available to us. It's basically like the Microsoft version of YouTube. So we created two sets of training videos. So the first one is the Climate Atlas introduction video. It's about a 5-minute long video, talks at a high level of what is climate change, where did the atlas come from, what types of data are included, and then we created a second video, which is more of a user guide. So how do you access the data? How do you process the uncertainty? What does that uncertainty mean? What is the difference between, for example, just directly using that data or taking a simple delta approach? And how can you interpret some of that data? So that is a much longer, more comprehensive video. The other thing that we've done is many presentations across the organization to different groups. So we tried to focus a lot more on the changes that were relevant to OPG, which has resulted in actually a lot of questions and interests. We were able to take that atlas, we were able to show people what sort of changes that we expected to see. And that has generated more and more people, again, looking at the atlas and trying to think for themselves about how they might be integrating that analysis. And what we plan to do in the 2022 to 2023 time period is develop some formal internal training for all of our engineering, our asset management, our analysis, our technical staff, to bring them through how do you get the climate change data, how do you integrate that into your business process, and how do you make good decisions based on the data that you're seeing. So again, putting all these together, the idea is that we are going to take care of 80%, roughly, right? The 80-20 rule. We want to take care of 80% of the different types of analysis, so that if someone has to go and replace a transformer, they have access to the data, they can do the analysis themselves, and they don't have to go back to a climate group because they have all the tools and the knowledge of how to do that. And so I wanted to give you a little bit of an overview of some of the changes that we're presenting that people particularly find meaningful. And so focusing a lot on RCP 8.5, number one, because there is not a lot of difference between the outcomes of RCP 8.5 and 4.5 until we start getting beyond the 2050s. But also we're certainly the changes that we're seeing here are a lot more dramatic. So for example, looking at things like the mean value of the maximum daily temperature, and I'm just showing this here for all of Ontario, but these maps exist for every single watershed in which we operate over these 30-year horizons. So here it's pretty easy to see what the difference in climate change is like. And these are examples of the pre-produced figures that we have available. So in this case, we've selected 3 different cities. This gives us a cross-reference or kind of a cross-section of the province of Ontario. So Toronto and the Great Lakes, Timmins is northeastern Ontario, and Thunder Bay is way in the northwest, getting close to the Manitoba border. And so we're able to talk through under the different representative concentration pathway scenarios, what sorts of changes do we see? We can see the different color degradation for the different probabilities of these 2 different scenarios. And again, here looking at, we do have a significant increase in the maximum daily temperature, even in the north. We like to look at the number of days with the daily temperature greater than 30 degrees. I find this particularly meaningful because it's something in particularly Southern Ontario people can relate to. When we're looking at, for example, down here, you might have historically a handful of days. For example, when I was growing up above 30 degrees Celsius, maybe 5 or 6 per year. Whereas we look into the 2050s, and now we're going to see almost 2 months. And as we get forward, again, this is just based on projections, but into the 2070s, almost 2 to 3 months of the year above 30 degrees Celsius. That's a real eye opener for people. That's something they have an easy time internalizing. And again, turning this into the time series map, the time series graph is something that catches a lot of people's attention. We can look at the highest 5-day precipitation amounts. So this is somewhat of an important indicator for hydro. We don't see a lot of change. And then we talk about our total annual precipitation. So the other thing that I forgot to mention is for the second edition of the Climate Atlas, we primarily focus on annual data sets, but certainly within PAVICS and within XCLIM, we have the ability to very easily redo this analysis for a season, for different months or different seasons. So what we've opted to do is actually present only the annual data rather than continuing to do all of the analysis. But if someone comes back where they have a particular problem or need at the time, then we can go back and we can modify that code a little bit and get them the specific data they need for those seasons. And the idea is at that point, then we would post that new data to SharePoint, that we'd be more responsive in doing that than providing an overwhelming amount of information at the beginning. So this is another good figure, is the total annual precipitation. Again, we can see slight increases. You can visually see that trend within this data set. And this is actually something I like to spin off to when we're talking about climate change, to discuss some of the sub-seasonal differences, because annual averages can sometimes tell you a little bit of a lie. What we're seeing here is an increase, but if we look across the province and we start looking on a monthly basis, what we do see is also a consistent trend of more stream flow, more precipitation in our January, February, and our winter months. We see relatively flat trend throughout the spring, but certainly a decrease in precipitation and stream flow across the summer. And so we have to be very careful, and this is a good point to highlight, is that it's not just about looking at the annual averages, because that can sometimes hide a lot of kind of very important and meaningful climatic signals. And the other one that I use within OPG is this threshold of cooling degree days as an interesting indicator. So what cooling degree days is it's the sum of heat units above 18 degrees Celsius. So the basic idea is this would represent the amount of energy you would need, for example, for an air conditioning demand. So it's sort of a proxy for energy demand. And obviously we can see it increasing with temperature, but the big thing here is, if you look at this between the 2000s and where we sit now into the 2020s, we've already almost experienced a doubling. And in that value could almost double again by the 2050s and quadruple as we get out into 2100. That's a meaningful indicator for people of what do we expect to happen in terms of our energy load if we don't grapple with the mitigation of climate change. So this ties into our broader resilience toolkit. So that's that map book, that atlas. It's just one piece of a broader toolkit that we're developing. And so it has a number of technical resources that are certainly still under development within that. So the Climate Atlas is a fundamental data set. We've also looking at developing some vulnerability matrices. We have some of these that were developed somewhat following the PAVICS framework. We also make available within that resilience toolkit any specific climate change report, any environmental assessments that we do, or reports in support of those environmental assessments related to climate change. That library is all there, searchable and readily available for everybody. So they don't have to go digging through corporate records or asking around to get the right report. It's just there. The other thing that we've really tried to highlight is to use say approved and publicly available data and data sources. And so this is something we've cautioned against within our atlas and everywhere else we look, to be careful that the data that we're using is a best fit or is relevant for Canada. We don't want to necessarily use data that's been downscaled within Europe, for example, for use as a Canadian reference, because each of these data sets, they're tailored to the organization that built them in the backyard. That's just a natural thing. So we want to make sure that what people are looking at is relevant to the Ontario context. And the last big piece of this that we're still under development is the OPG Resilience Guide. So this gives us more of our process tools for integrating climate change and uncertainty into our engineering decision-making. How to look at those extreme events versus normal. What is the impact on our reliability? Focusing more on our risk-informed decision-making. And so again, all this is available for everybody with the Resilience Toolkit SharePoint site. And so this major SharePoint site is actually hosted on our enterprise risk management team. And then they link to the various groups. So for example, my group is actually hosting our Climate Atlas, our climate change assessments, all of our Lake Ontario data. There's another ERM is looking at transition risks. They also host some of our vulnerability matrices. And then we've got documentation and links to the various business processes where climate change has already been integrated. And so as a very quick introduction to the resilience guide that we're still in the process of developing, is the idea here is that we're going to identify our critical vulnerabilities. We're going to do the analysis that's required for the problem that we have in hand. So for example, if I'm at a pre-planning or a very conceptual stage, I don't need to go and get high resolution downscaled climate data, because I can probably make some reasonable decisions with some very simple analysis from my climate atlas. Now, if I'm getting to the point where I'm going to rebuild a new, very expensive generating station, obviously I want to have more complexity. I want to have more details. That's where our climate expert group would get involved. So the idea is to have a framework that would scale to, number one, where are you in the life cycle of your project or your assessment, but also in terms of the need and the complexity of the design that you're going to do. So kind of taking from Albert Einstein, everything should be as simple as possible, but making sure it's also no simpler. And so the resilience guide that we are building is very heavily based on the climate risk informed decision analysis framework developed by UNESCO. And so with that, we've also incorporated into that resilience guide a lot of the lessons that we've learned through the various projects we've done with Ouranos, things that we've seen from the literature of how to understand and deal with uncertainty. So it's a fairly comprehensive document. But in terms of the actual step-by-step process, I certainly favor this CRIDA approach. And so the main sort of 5 steps of that is to, number one, set your decision context. What are the drivers for the particular project that you're doing? What's the level of performance you expect? So, for example, is there a temperature threshold that becomes very important and beyond which you need to adapt? So following that, we would move into step 2. You do your vulnerability assessment. So you look at, for example, if I was looking at a transformer, I might look at the impact of the stress that's imposed by a changing temperature, but also a change in demand. And so I'd be looking to see what become the critical factors beyond which I no longer have acceptable performance. From that, we look into step 3 of developing essentially an action plan. Is this something that I need to do now? Like I need to take a robust action, I need to upsize that piece of equipment, or that I can monitor and I can take potentially an action in the future. At that point, I can replace it, I can add a cooling fan, I can do different steps. And so then we start to evaluate those options in step 4, come up with our business plan, and then we institutionalize those decisions in step 5. So that's a very, very high summary of what's within that CRIDA guide. So I would encourage you to go and visit that website. There's a couple of YouTube videos as well that will give you a better understanding of that process. But the key is that what we're looking to do is, as we're participating in our asset management lifecycle, that's when we're actually integrating climate change. So I don't want the report that's sitting on the shelf collecting dust. I want to say, okay, I've got to go and I've got to replace something, right? I need to undertake a project. This is the time for me to actually do the consideration of climate change. And so what I'm doing now is not having an adaptation project. What I'm having is a project because something has reached the end of its life and needs replacement. And now we are building resilience onto that. We're taking a forward-looking view as we replace something so that we can actually take the information on climate change. We can put it into real actions on a project that we're spending money on anyways. And so this last little section that I've got, I realize I'm coming to the very end of my time, sorry, is the upcoming use of XCLIM. So one of the challenges that we have in our operational flow forecasting models is we do have a bias, and we've seen that between the data that we're using for our training data set, which is the Kappa RD RS reforecasting system, and our Environment Canada's primarily what we've looked at now is the global ensemble prediction system. And so sometimes these two products over a period of a year can have a difference of 200 millimeters of precipitation. It's pretty significant. And so we're exploring taking data from CASPAR, from the operational data that we've been collecting, and using various XCLIM algorithms to do some of the bias correction of that data set. And so the initial results, I'll say, are fairly promising in that we can correct some of those major biases. From certainly the people with a lot of familiarity of climate change, you're probably almost pulling your hair out going, wow, there's only 3 years of data in that JEPS archive. And that is also a barrier that we're looking at. It's not a full 30 years of record to get a reliable sense of the climatology. And so that continues to be one of the struggles of how do we deal with the fact that we've got such a short period of record, but we are finding also a meaningful improvement. And so that is the end of my presentation.
Thank you, Kurt. That was really an excellent tour and story of what happened recently at OPG. I'm very impressed ever since we did the tour of presentations a few years ago. It's great to see how you're kind of implementing in-house climate services and moving that forward. That's very impressive. I think I have one question here in the chat that I might just forward right away. Leslie says, thank you, Kurt, for your presentation. Do you have practical examples of how these data are used in day-to-day operations or dam safety or project design?
Still very limited. So one of the challenges is continuing to roll out the training so that people know how to use and integrate that data. I believe some of it was actually looked at for a transformer upgrade. So people were looking at the specs of that transformer, and they were able to look at the impact of climate change and almost a very simple analysis to be able to justify, for example, increasing the spec on that transformer to build climate change resilience. In terms of the dam safety, that is actually a much more complicated topic. So in terms of looking at some of those inflow design floods, the Atlas simply isn't built, let's say, to answer those types of questions. And what we've relied on there is much more the types of research projects and analysis that we've undertaken have been documented with Ouranos. So we've used that as some of the, let's call it the justification or explanation of why we have or haven't made a design decision change.
Okay, thank you. Alain put a question in the chat. Alain, do you want to ask your question in person? No? Okay, I'll ask Alain's question. Did you get input and comments from users within the company? Are you monitoring the use of developed resources?
Yeah, so the input that we've received so far is generally positive. I would like to see more uptake of the resources than what we have seen. And that's part of making sure we do integrate it into the processes and into our governance. People will sometimes not use all the resources available if they don't have to, right? People are going to do what they're forced to do to keep their projects moving. So it's actually a really important part to make sure that we do come back and we have that in the governance to get that day-to-day use out of it. So we do a little bit of monitoring of the use of those resources. We get hit counts, for example, from SharePoint.
Okay. Sarah Claude, do you want to ask your question yourself?
Yes, can you hear me?
Yes.
So really nice presentation. Thank you very much. So I was wondering, how do you tell engineers how to handle the uncertainties in climate models and projections?
Yeah, and so that's where we follow the guidance of the CRIDA framework. So one of the challenges we get whenever we go out and we talk to an engineer about climate change is they say, give me the number, right? Okay, so I've got to design something that's going to last the next 50 years. What's the number I need to design to? And as you know, with the uncertainty, and we don't even know what the true scenario is going to be as we get out into the 2080s, 2070s, the simple answer is I don't have that number. And so what we use under the CRIDA framework is it's more of a risk-informed approach. is what we're trying to move people onto. So the idea of is how much confidence do I have that I'm going to pass that threshold in the next little while? I'm going to pass that level of stress that concerns me. And then from that, you would do sort of a, is there any kind of mutual wins or quick wins? Or you would do a cost benefit analysis to say, I'm going to build so much resilience. And then for that, you know, that increment that might happen in the 2070s, what you're going to do is you're going to set up a monitoring program, and you're going to have sort of a pre-developed plan of what you're going to do if you ever cross that threshold. So there's, within that CRIDA framework, there's actually a series of sort of steps looking more at the level of stress that your system's going to undertake than focusing on the potential uncertainty of a climate model and saying, here's the number for you know, a 2070 design. It's a very short explanation. It really doesn't do it justice, but there's a lot of documentation there.
Perfect, thank you.
I have another question here in the chat from Cherin Akari. Cherin, do you want to ask your question yourself?
Yes, sorry, I'm a bit noisy because my husband is doing some other meeting, and I apologize for the noise I made previously because I was able to switch to my phone and was not able to do it. So my question is, thank you, Kurt, for this nice presentation. When you were showing the slides, I noticed that I think you were using on the Atlas, Climate Atlas data, you were using the incident mean value instead of the historical value from Natural Resource Canada. Can you please explain why? Is it like more accurate to use the 24 or the 23 models we have on the climate data versus the historical data that comes from Natural Resource Canada? Thank you very much.
So the reason we did that was to provide a consistent data set so everyone can see what the trends and the changes are. But then within the Atlas and the user guide itself, we explain about the use of historic data, doing the comparison. We do have some of there's the NRCan, the gridded data set. I'm very much looking forward to the new sort of CAPA, the RDRS reanalysis is coming out of reanalyses. I don't know what the plural of that is, but coming out of Environment Climate Change Canada. So we want to be able to use that, but also give people the flexibility to use their site-specific data. So they could also go and just extract, for example, from their local weather station. So I don't want to presuppose the types of information that is important to people, but we do explain within that atlas the difference between looking at the historic value and how to do some of those comparisons.
Thank you very much.
Okay, great. Thank you. To close off that great conversation, Kurt, I have a question. Where do we go from here? What do we plan next to collaborate? What's your next questions and needs within the consortium?
Oh boy, yeah, we have.
we can probably carry on that discussion later, but I thought I'd throw that out and see what your thoughts are. Yeah, so for some of us, we want to be able to expand that atlas. We've got a lot of questions. So that is just the climate data. We're having questions on, for example, what's the intensity, duration, frequency curves of rainfall? How can we look at that for our drainage systems? We're getting a lot of questions on Great Lakes water levels, as I see Biliana has flagged in the chat as well. So those are topics. And the other one for us is some more of the integrated risks related to climate change. So one of the things that we're trying to bring up more and more, for example, is the risk of wildfires. What's that intersection between temperature, rainfall, stream flow? And then as you have that change to your environment, so as you burn up all the trees, you are going to get a different sort of hydrological response in the watershed. Mm-hmm. So those sort of compounding multi-risks, those are the kinds of challenges that I'd prefer to put our kind of climate experts on. Okay, great. Once again, thank you for that great presentation.